All right, sup everyone. This is the week one of oh my god, sorry, of my progress. What I'm doing here is I'm gonna try to journal everything that I do until I master AI. And that my actual idea here is to make a little video, just showing what I did. Um, so I'm actually have a little bit of a motivator. So I go, you know, I'm making these videos. I have to make a video showing people what I did until the end of the week. Yeah. And if I didn't learn anything during the week, well, I'm gonna be ashamed because they're gonna notice that I've either not done the video or I've done the video poorly, and it's just a way for me to keep track of what I'm doing too. Yeah. So I have. It came to my science that linear algebra, differential calculus, and Python. They're very important skills. They're actually things you need to know, things you need to master if you want to know anything about AI at all. So that's where I'm going to start at. And I'm going to be showing you guys what I learned this week, firstly on linear algebra. Now, I do have a little bit of knowledge of linear algebra because I actually failed it in college last year. So, yeah, that's yet another motivator for me to putting the effort and truly learn it. So yeah, the first thing I learned here was, of course, the introduction to vectors, the two forms that they can be expressed, which are for some reason rectangular forms, uh, which is like this, in which you put in the x first and then the y. I don't know why Khan Academy calls this rectangular form. This doesn't make much sense. And the second form is through matrices. So yeah, pretend is a single bracket here. 2, 3 matrices. So yeah, that's basically it, and showing the different forms. The second thing I learned was how to sum two vectors algebraically. So you take the rectangular form, you sum the x and the x and the y and the y, and if you have more dimensions, you can you have to sum them accordingly. And graphically is when you take different vectors and you put on a line and you connect to the line from the beginning of the first vector to the point of the arrow of the second vector, and that's gonna be the sum. I still gotta review that a little bit because I tried doing it on GeoGebra and it didn't go well. The product of a vector and a scalar, so basically scalars are like a normal real number here. So you could have like a vector 2, 3 here and a scalar 2. V times k is going to be 2 times 2, 3, which actually translates to 2 times 2 and 2 times 3. So the 2 kind of gets in and multiplies each axis, and this is gonna result in 2, 4, and 6. So yeah, this is how you sum vectors algebraically. I know I said I wouldn't explain anything. I'm just trying to organize my thoughts. And introduction to unit vectors. So basically have uh, the first one on the two-dimensional place is 0, 1. So they're basically vectors with a magnitude of 1 that their only purpose is to show is to demonstrate directions. So the first vector here is only going under the horizontal direction, and the second vector is going up, let's say like that. And you can use these unit vectors to express the direction of other vectors. So for example, let's say 5, 2, it's going 5 blocks on the x-axis and 2 blocks on the y-axis. And then you can use -2 uh, or positive 2, negative or positive 2, to express if they're going up and down. This is probably very useful on physics. I actually know it is. I just don't know why they're useful on the AI yet. I hope I get to know soon. And then into calculus. Now calculus I'm just reviewing because I know a little bit of calculus already. I haven't failed it, so yeah. So I learned about how to estimate the value of limits using graphs. So basically you take the graph of a random function. Let's say I had it here. Y equals to x squared, and then you can say like, oh, what is the limit of x squared when x is approaching 2? So as we go on numbers like 1.9, 1.99, 1.999, you know, like very numbers that are very close to x. Tendency is that the function is going to result on 4. You know, wait, just give me a minute. I didn't want my cell phone to ruin the video. and yeah, infinite limits now. Well, to be very honest, to me it just sounded like exactly what I just showed you, how to estimate the value of limits using graphs. But for some reason, Khan Academy tells you that when a function tends to the infinite on a certain x, the limit just doesn't exist or is undefined. I don't know why they did that. Anyways, then left and right hand limits. I actually heard about that last year, and it's basically like, okay, we're going through numbers very close to 2, but that are greater than 2. That's right hand limits. So 2.1, 2.01, 2.001. What value does the function return when we provide those x's? Let's say when we provide those values to the function. In this case, they would give us some like 4.01, 4.001, you know. So the function is tending to 4 when we get closer to 2, using values that are greater than 2. Okay, but when we are getting close to 2 with values that are above 2, or my bad, below 2, like 1.9, 1.99, 1.999, when we provide those values to the function, what does it return? It's going to return something like 3.9, 3.99, 3.999, you know, values very close to 4. I'm sorry for this sound over there. Okay, so they match each other. They are, you know, heading towards the same number, which is 4. So the limit of the function x squared when we approach 2, when x approaches 2, is 4. That's basically what this whole thing is about. Now on to the fun stuff, which is programming. Like I think I said, Python is useful, very useful, one of the best languages to learn for AI. So I've actually learned a little bit more, but that was before I came up with this journaling idea. So wait. What I learned this week in Python, it's just exactly this. So positional arguments, you know, the first argument that you provide to the function is this first argument that's going to be processed in the function. It's going to be received on the function, let's say like that. Default arguments, so maybe I don't always have a certain value for an argument, so I can just give it a default value. Keyword arguments, so basically I can how can I say, I can provide the variables in a different order. That wouldn't work on the, positional arguments, because the function that only takes positional arguments is gonna take that exactly first value as the first value that we should. I don't know how to explain that any better than that. It's kind of an intuitive thing. I made I made these notes. By the way, I'm following Bro Code's 12-hour long video on Python, on so you can master the syntax of Python and all of that. If you wanna watch his video too, it's actually pretty good. I've learned quite a bit of it using his video. I'm gonna leave the link in the description. But these are my notes I took from his video. And arbitrary arguments. Now these were actually pretty interesting. So we can, let's say you don't know how the print function. If we look into the code of the print function, the core code of it, we would probably see an arbitrary arguments variable when receiving the arguments, because we don't know how many values the coder wants to print. So what we do is we use this asterisk, I think that's how you pronounce it, asterisk args variable right on the parameters of the function. So this is actually going to turn into a tuple, and then you can loop through that tuple and do whatever you want. You can even use the methods of that tuple on this actually same variable. Now he said that it's good practice, or it's common for coders to use these. Oh my bad. For coders to use these names, args and keywords, because it stands for arguments and keyword arguments. And yeah, keyword arguments take two asterisks, and they become a dictionary. So you can actually take values using keys, because that's actually what keyword arguments are all about. Membership operators, they're pretty easy to here. Basically, they return true or false whether a value is inside of an irritable or a collection. It could be a collection. I forgot about this. It could be a collection, or it could be an object like a string. So here in this example, I had a apple string, and I asked if a is the word. The output would be true. If I use not, I'll be kind of like denying true. And when you deny true, when you use not true, this is going to give us false. So basically, would say, is A not in apple? Well, no, because A is in apple. It's kind of complex just speaking like this, but when you actually put it into code, it becomes quite easy. List comprehension. Now, this was probably the first most amazing thing I learned this week in Python. You can literally generate lists. You can save up to like 5 lines or something like that. You can generate full-on lists with a single line. So the body of list comprehensions are literally this. You have an expression. You can even put a function here. I don't know I don't remember if he mentioned that on the video, but you can literally put up a function here and give x, or the variable that you're working with, as the parameter. And I'm sorry, I'm kind of sick. And whatever that function returns, or whatever this expression returns, is going to be put in the list, or in the tuple, or in the dictionary, whatever you're doing. And you can put up a condition here. Yeah, I can put up a condition here. The actual body, full body is here. So expression, do the expression for each, return the expression for each element in an iterable. So here I had range, but I could have a list, for example. And I can put a condition here. If I put a condition here, this is gonna filter the elements. So the elements that don't meet this condition, they're not gonna make it into the final list. If I put this condition that's right over here, then I'm probably gonna need an else statement. In fact, I'm gonna need an else statement. I've already checked it. So you can do something else with the items that don't meet your requirements. It's something crazy. I'm not gonna go into depth with it. Go watch Bro Code's video. It's great. It's great. I'm just gonna show you guys. I'm just showing you guys what I did this week. Match cases. At first, it seemed really dumb. The core idea, they call this switch for some reason. The core idea is that like you don't want to have all these else if statements because your code is gonna look ugly. So instead, you match your variable and you kind of compare them to these cases. So instead of having like if day is 1 or if day is 2 or if day is 3, you're gonna have to write all that like I did over here. You literally just say, okay, I'm comparing this function, this variable here, to this result or this result or this result, and if the variable is equals to this result, then you should do this. You should return Sunday, or you should do something else. You know what I'm saying? And if none of these requirements are met, which on else if statements would be like be equals to else, you do case wildcard. I don't know why it calls wildcard, but that's what it is. And you can return something else. Pretty easy. And finally, modules. Now, I'm probably not going to be able to show you modules here because I have to open VS Code and etc. And the video is probably getting pretty long. But you can now I know how to make other files, different files interact with each other. You can using the import word, so import and the name of the file. This is actually a library, but you can actually have the name of the file. How to give what he called nicknames to whatever you imported, and how to import a single variable or a single function from a given library. You can even give the nicknames to whatever you imported. Yeah, that was it for this week. So I'm not gonna ask you to subscribe. If you want, you can do that. If you don't want, literally all this channel is gonna be about is me just showing what I did every week until I master AI. Well, thanks if you watched all the way till here. Looking forward to see you next week. Good evening.